This is exercise 45. On this exercise, we are going to be optimizing a whole sequence for a bunch of holes that are not aligned. The contents: view the operation for a sequence that is not aligned. Change the drilling sequence. Reload the editing list. We're going to open the part, and the part is already here. We're going to start by viewing the operation. Right click in the background of the graphics window and choose Orient Top. In the geometry view of the operation navigator, double click the whole boss geometry node. Geometry, double click this one. In the whole or boss geometry dialog box, in the feature group under the list subgroup, select any item. Okay, let's see this item. We're gonna select any item, so we're just gonna select number 7. This will clear the features CSYS vectors from the screen. Under the previous subgroup, click Display. Under the previous subgroup, click Display. Here. All right. You have used a SIG or zigzag hole sequence, but we have unwanted passes that you would like to minimize or remove. You want to specify a band width that allows NX to include holes that are not aligned in a single pass. Page 4. Next step is change the drilling sequence. The objective is to change the drilling sequence. In the sequence group, set the following: optimization, primary direction. In the sequence group, set the following: sequence optimization equals primary direction. There. Direction equals YM. Here. Pattern zigzag. Here. Click reorder list here. Okay, now it looks different. It looks better. The sequence looks better because hole 7, which is the center hole, is 2 millimeters out of alignment with the hole 5 and 6. The tool path cannot include it in a single pass. I see. In the bandwidth box, type 6. In the bandwidth type 6. Enter. Click reorder list. The bandwidth, which is centered on hole 5, is now wide enough to include the center points of holes 5, 6, and 7. The sequence is reordered so that the hole 5, 6, and 7 are drilled in a single pass. Holes 8, 9, and 10 on the right side of the part are farther out of alignment. They require a much larger bandwidth to be included in a single pass. Got it. Page 5. In the bandwidth box, type 54. 54, enter. Click reorder list. There it goes. In this case, reordering changes the position of hole 8 in the list, with the band now centered on this new first position. The 54 millimeters bandwidth includes holes 8, 9, and 10 in a single pass. Now you will reverse the drilling sequence. In the sequence group, click reverse list. Here, reverse list. The start and end points of the toolpath are reversed. Hole 1, the first point in the bandwidth, is now at the lower right corner. The lower right corner, which is here. As a result, the band will center on this hole. Click reorder list. Reorder list. There. The band shifts to the right, centering on the first hole. The third hole, now hole 3, is no longer contained inside the band. As a result, holes 1, 2, and 3 are no longer drilled in a single pass. Got it. In the bandwidth box type 60, click reorder list. All right. This bandwidth is now wide enough to contain holes 7 through 10, but still not wide enough to contain holes 1 through 3. Holes 7 through 10 are now drilled in a single pass. In the bandwidth box type 70, all right, 70. Click reorder list. Holes 1 through 3, 4 through 6, and 7 through 10 are each within the bandwidth and are each drilled in a single pass. Click OK. All right, we click OK. Next page and next step, reload the editing list. In the geometry view of the operation navigator, double click the drilling node, which is this one. Double click. Click specify feature geometry, which is here. Click reload order from parent. Where was that? Reload order from parent is here. There. The sequence in the operation now matches the sequence defined in the geometry parent. Is it? Click OK to return to the drilling dialog box. Generate the operation. We say OK. And then we generate the operation. Okay, yep, that's what we want. Click OK to complete the operation. Close the part without saving. Before that, we're gonna go to the isometric view. And we're just gonna see the toolpath really quick. All right. And to understand it a little bit better, we are going to measure the width and the length of the part to understand why we were using those values on the band width. So we're going to measure this one. This one is 150 millimeters. And this one is 200 millimeters in length. All right, and that's it. So we stop exercise. We stop the video of exercise 45.